Thank you, Abigail, for the introduction, and thank the Tech Symposium for having me here. And just so everyone knows that the question and answering is working, I also see the question. So my favorite food is New York pizza. So we all have our favorites. One of the things I wanted to do today is to carry the theme from yesterday's panel on maximizing the value over the air traffic management digital transformation. Today, I want to dive a little bit deeper on how the FAA can leverage digital engineering and transdisciplinary thinking to help accelerate adoption of new technologies and help the organizational and cultural transformation that come along with this digital transformation.
Doug, just an FYI, your session or your PowerPoint is in presenter mode.
Okay.
I want to turn it on slide deck. I'm sorry to interrupt.
Yep, sorry, no problem. I probably shared the wrong screen here. There we go. Over my career, I've worked at various organizations, almost kind of within digital engineering and evolving my practice as an engineer with the newest and greatest methods in digital engineering over the last decade. It's evolved from traditional modeling simulation to now system modeling language techniques to now really becoming a transition period of having all this data within the engineering realm be integrated together. And it really aligns with the fourth industrial revolution. If you look at history during each of the industrial revolutions, they all have had three phases in common: the installation period, the turning point, and deployment. The information age is here. We are in the turning point, rounding the bend into deployment. The information has affected the way we live, work, and relate to systems. For National Airspace System, you're beginning to see disruptors to what is known and was very once predictable. SpaceX, Amazon, Google, Virgin, and many others are pushing the National Air System to be more dynamic by challenging the NAS to integrate to new business models beyond what we do today. Just look at the emergence of keeping airspace under 400 feet safe, between personal unmanned aerial vehicles to pushes to use UAVs for the last mile of delivery. Congestion of this critical airspace will not just be driving economical consideration, but a huge public safety consideration. We need to be able to use technology to better understand the problem and how we can solve these issues. Even looking at traditional airliners, we have seen a change. Airplanes are now carrying so much data at the edge that we need to see how we can empower this data in a new paradigm of Internet of Things and distributed workloads. Another trend that you would see during each revolution is the time to get the deployment has shortened. Just looking around at the enterprises that we were here just a decade ago, they're not here today. Toys R Us, many other businesses, they all failed by not accepting how to use the technology for their business and their objective. For the FAA, it is no different. To keep up with the changing world and providing a safety to our national airspace, we need to embrace technology. We need a mechanism to not let technology surpass the capacity we're able to adopt in a rigorous and safe manner. And I truly believe that in order to be able to adopt these new technologies, we also need to update how we assess and analyze these technologies for adoption. So how did we get here and got these demands? Technology has evolved for the consumers and users and how we want to use technology. Our requirements for systems has increasingly become to be more resilient, scalable, sustainable, and socially acceptable. We can't just look at technologies to help us transform, but we need to relook at policies that will allow the transformation to happen. We need to be able to respond not in 5 to 10 years, but find new methods to respond at the speed of relevancy. This will allow us to expect success in safety critical fashion. In the words of yesterday's panel, we need to get a way to say yes faster. And we need to synthesize historical data that we have and the data captured day in and day out. Use the data to build trust into the adoption of new technologies and solutions. Rethink operations that will allow us to blend the new realities of the NAS. Push the NAS to meet the needs of the traditional operations and emerging unmanned autonomous vehicles, hypersonics, and space operations. The reality is we need to look at how NAS will adopt these new emerging technologies while continuing to improve and provide a service level of safety to the public. As we have seen in this past year with COVID, we need systems that can bend but not break, that can react and evolve into new realities quicker than ever before. How can we leverage big data analytics augmentation to assist controllers? How can we use data visualization, augmented reality, and virtual reality to provide better situational awareness or training to controllers, needing to adjust to new technologies? The adoption of these technologies will change current paradigms, and what we need to ensure is we are able to analyze and predict emergent behaviors of its adoption into the NAS. By using transdisciplinary thinking, we can look at the NAS for what it is, a social cyber physical system, where the human is key to its success. Human system integration and how we evaluate for it will be key to the success of the NAS. With the introduction of automation and analytics, operational tactics, techniques, and protocols will also need to evolve. This will require new training across the enterprise, new systems that will enable success. And human system integration, to me, it was a 6-year journey for me to actually do a lot of research in this area as part of my doctorate, and really understanding how humans get architected into the system, how our cognitive abilities can affect the system performance and optimization. And really, in order for us to evolve and use a lot of these technologies, we have to evolve the processes and methods and how we design these technologies into the systems themselves. I like this quote from John Cotter's book, Accelerate. The world is changing at a rate at which the basic system structure and culture built over the past century cannot keep up with the demands being placed on them. The reason I like this is because digital transformation goes beyond the technology. A lot of our technological needs today could be and can be answered through what the technology that we have today. The bigger question is how we can take these systems and transdisciplinary thinking to analyze how we build these systems and how we acquire them to get fruitful benefits with this technology. How we change our paradigm on adopting these technologies, and changing our policies to be open and agile enough to accept these technologies into safety critical systems. If we want to adopt these new technologies, we need to revamp our acquisition system for the information age. Find safety critical methods to ensure trustworthiness of integrations. We need to look at how we build an innovation environment where the system of innovation can produce a modernized, innovative system, in our case, the evolution of NAS. Through the various technologies mentioned, we can create this system of innovation enabled through a digital engineering ecosystem. So what is digital engineering? Digital engineering is an integrated approach that uses authoritative sources of knowledge to support lifecycle activities from concept through disposal. Digital engineering combines model-based techniques, digital practices, and computing infrastructures to enable the delivery of high payoff solutions to end users at the speed of relevancy. It modernizes how scientists and engineers conceive, design, operate, and sustain capabilities. We are able to make connections between data that were once isolated in one engineering discipline or tossed over the fence to creating a set of authoritative sources. Working together in a digital thread to seamlessly expedite interoperability between stakeholders, informing decision makers with context into actionable information. What was once institutional knowledge of few becomes transparent to larger enterprises, enhancing communication and increasing confidence that solutions will perform as expected. Models and data can be used to increase the understanding of the system to achieve greater flexibility and adaptability during and after design. The importance of digital engineering will be the ability to create virtual test beds for concepts much earlier in the system lifecycle to adjust requirements and finding gaps in meeting FAA objectives. To be able to connect data across organization and use tacit knowledge of the community to solve major negative disruptors, like COVID did this whole last year. Digital engineering presents a new opportunity for us. It allows us to better collaborate across organizations, across disciplines, to really take that transdisciplinary approach. Yesterday, during the digital transformation panel, Leanne Ridgway from Collins Aerospace and Rebecca Guy from the FAA spoke about how simulation could have a greater importance to the digital transformation of the FAA. Beyond the more traditional modeling simulation capabilities or integrated requirement and architecture descriptive models, digital twins present a huge opportunity. A digital twin is an integrated multi-physics, multi-scale probabilistic simulation of an as-built system enabled by the digital thread, and uses the best available models, sensor information, and input data to mirror and predict performance over the life of its corresponding physical twin. The physical twin being the operational system that is fielded and being operated and sustained. A digital twin can create a comprehensive approach to realizing how the adoption of these new technologies could impact NAS. Through methods like multidisciplinary analysis and optimizations, engineers can assemble workflows across disciplines and organizations to run design of experiments and optimize results for parameters of interest. Mantech has done this for space operations, where early integration studies once took minimum of 18 months of manual labor to evaluate. We can now do this in days to weeks by automating workflows of various models together to create early integration studies of these launch vehicles. This distributed environment not only allows for subject matter experts to design the workflows, but the decision makers to see the results and toggle through designs and scenarios to trade the results. The multiplication of design cycles allows engineers to explore more of the problem space and solution space that traditionally we were not able to. We are now only limited by computing power, which with every day passing, the higher usage of high power computing becomes more accessible through cloud providers, and push for quantum computing has accelerated our ability to run very complex integrated trades and build higher level fidelity models into those trades. As a company that provides cyber solutions to our customers, we also put focus on moving digital twins beyond the form and fit of physical system characteristics. We're also integrating the cyber considerations. Developing a cyber physical digital twin allows us to see how command, control, communications, computers, and cyber get affected through everyday operations as well. Given the situation with the Colonial Pipeline recently, this capability to be able to virtualize the whole system in its current state can allow us to better harden and analyze vulnerabilities against cyber and physical threats. Give us a true test bed that will assess physics-informed cyber behaviors as well as cyber-informed physics behaviors. This platform allows you to reduce risk in your DevSecOps pipelines by using live test beds with up-to-date state of the physical twin in operation, ideally reducing risk to push updates to software or hardware out of the operational system, and getting to the yes with all the critical safety checks without disrupting current operations. The flexibility of these live test beds allows us to run scenarios until enough risk is burned down and still allowing us to test against real operational data seen in operations. So we are in the turning point in this technological revolution of the information age. For us to ensure success, we must take a transdisciplinary approach and consider what emerges from the digital transformation. We need to change our vision to agilely accommodate unforeseen technical opportunities, get the yes quicker, but with the same rigor and level of detail. Change our culture from the vicious, rigid requirements to a dynamic, agile evolution of requirements. Look at emerging requirements and how quickly we can adapt and ensure safety and update operations. Change our methodologies from traditional system engineering V approach to a more elastic digital engineering approach, using new methodologies for discovering the art of the possible and setting up transparency across the enterprise. Update our tools to include digital twins, multidisciplinary analysis and optimization, data analytics, machine learning, and AI. Let's not just integrate emerging technologies to the system of interest, but the system of innovation. Update our knowledge of more education and training in modern digital engineering environments. Digital transformation is more than integrating new technologies, but it's a cultural and organizational paradigm shift. A time to reflect on how we improve to adjust to our new realities, especially given this past year. And most importantly, evolve our policy and governance to meet the demands of emerging airspace needs and adoption of technology. We have early opportunities to use predictive data analytics, machine learning, and augmentation that will build trust and confidence in these digital technologies and the application of them. Similar to current mandates incorporating AI into FAA, other mandates and policy changes should be analyzed to meet current demands. And with that, I want to thank you, and I want to see what questions I could ask, I could answer from the Q&A. So one of the questions in the Q&A is, how do you propose to being the process of evolving the FAA technological infrastructure to take advantage of the changes you have described in your talk? So digital engineering has been a big push, by many, and it was actually, mentioned in the panel yesterday, that it has been really being pushed by the DoD. And a lot of the other federal agencies are now coming up to speed with what digital engineering is and how it can be applied. Many of the best practices for digital engineering as it evolves, right? And as we hit the deployment of digital engineering into practice, into day-to-day practice, and creating systems that are born digitally, a lot of that is an infrastructure question. And in order to push ahead and have these systems be born and operated in this digital fashion, one of the best lessons learned that the Air Force has been using is to create an ecosystem that the federal government owns, and that providers, contractors, stakeholders can all be part of. That doesn't mean that the federal government owns all the tools, doesn't really mean that they own all the data, but it does create a area of collaboration. And really, from a governance perspective, the FAA would need to look at data rights as contractors deliver their capabilities into the NAS, how we can create modularity, so we can reuse these models that are being delivered to be able to be connected together. Looking at different technologies of interoperability of data. In essence, this is a data problem, and you don't want data paralysis. And part of this engineering paradigm shift has been, how can I expose data, and then how can I use that data and empower that data to make me empower myself to make decisions. So overall, I think there's going to be an evolution as FAA begins this journey to potentially use digital engineering in ensuring that our networks and infrastructures are secured and optimized for the reality of today, for how new systems can be delivered from a digital first mindset. And with all of that, I truly believe that the transformation can happen. Second question I have, and I'm not sure how much more time I have, but I'll answer this one. How do you maintain the FAA's outstanding operational safety record while absorbing all this change? So part of this is that you're not going to do this digital transformation, or any transformation shouldn't be a whole hum effort. You really want to get these initial wins with real high value. So you're not going to go in and say from day one to day two, we're going to be all digital. I think there's a transformation process that needs to happen. A lot of this has to happen in a very iterative fashion. Getting first wins. Starting out with how do I move our acquisition to a digital state, and taking what those increments could be. Instead of having RFPs that are fully documented, starting to change some of that into providing models as a way to acquire system, and requiring models, right, to see how contractors are meeting requirements, and then slowly evolving that over time. In the DoD, that's been almost a 10-year journey, and I think because they have set the pathway into what is being done and starting to build systems that are born digital, I think there's a lot of lessons learned that we can pick from that to accelerate the transformation at the FAA. And from a safety perspective, one of the things that in my past, as I worked in digital engineering, has been using digital engineering for power control systems for modular nuclear reactors. And those regulatory bodies, they want you to prove, just like the FAA, that their safety is paramount. And in order to do that, I believe digital engineering allows us to really look and take the rigor of integrating safety into everything that we do. and be able to analyze that and keep up with that heritage. Abigail, do I have questions for more, or
yeah, you have 2 more. You have 2 more minutes, so I think you have time
great.
to answer one more, and then we can come back to you if there's still time at the end.
All right, great. So I'll answer one more question. So there was a question on whether this was Kessel Run. So Kessel Run is one of the many ways that the Air Force is trying to transform. But that's just one. So Cloud One is an environment and an ecosystem infrastructure where a lot of the digitally born systems are actually going to be developed in, where a lot of the OEM contractors, as well as the system engineering technical advisors, the system integrators, and the customer themselves are able to collaborate, be able to distribute modeling simulation capabilities and models. And they're really building that ecosystem up to be able to house and own the technical baselines, but not just owning the data, but understanding the context in which the data lives. So Kessel Run is definitely a part of it, but as we move forward, I think that there's a larger ecosystem that needs to be built out.